What's up, guys? It's Tech, and today we are going to go over a bisection method problem. So the bisection method is used to find the roots of an equation, and it's kind of like a guess and check method. So it's going to require multiple iterations, and the more iterations, the more accurate you're more likely to become. So for our problem, we're given this equation fx is equal to 0.5x squared plus 2.5x plus 4.5. So you could solve this equation using the quadratic formula, so that would be a good way to check your answer, or you could use the quadratic formula to calculate your true error. So in our problem, we are told to do 3 iterations with our lower bound starting at 5 and our upper bound starting at 10. So the bisection method is basically taking the middle between these two here, 5 and 10. You're taking the midpoint. So our first guess, our XR, is going to equal XL plus X upper over 2. So it's the X lower plus the upper over 2. So that's just taking the midpoint between our lower and upper points. We're also going to want to be able to calculate the absolute error, which is basically telling you the error from your last guess. And that's going to be x upper minus x lower over x upper plus x lower. And it is the absolute value of that. And you could multiply that by 100% to get a percent. Lastly, we're going to want to know the true error. So the true error is going to require you to have the answer to the problem already. So you already need the root. So the root is x. So you could do that by quadratic formula, or maybe the problem might give it to you. And that's the absolute value of the root minus your xr over the root x. And that's going to give you true error. So now we can just jump into the problem. Now I've already solved this, so I'm going to go over it step by step with you guys. So the first iteration, we're going to want to calculate our XR, our X guess, by using this equation here. So we have our X lower 5 and our X upper 10. So 5 plus 10 over 2. That's going to give us 7.5. Now what we can do is calculate our true error. So that's this equation right here. So I already calculated our root using the quadratic formula, and the root is 6.40512. So now by plugging that into our equation for true error, we get 17.09%. Now we can calculate our absolute error using this guy right here. So it's our x upper minus x lower over the x upper plus x lower times 100%, and that's going to give us 33.33%. So normally absolute error is going to require you to do at least one iteration to get it, but the bisection method is a little bit different, so we're allowed to use this equation here for our first guess. So now what we want to do is plug in our XR and our XL into the equation after we calculate our XR. So we want to find f of XL and f of XR. And we're going to multiply them. And what that does is check if there's a sign change. So basically, I'll draw this out on a line for you to make a little more sense. So basically, we're looking at this range here from 5 to 10, and we're looking for a root. Now we just calculate our XR right here. Now if this is positive and this is positive, that means that there are no roots in here, and the root's going to have to be in here. So that means you're going to want your XR to become your lower root and 10 to stay as your upper root. But let's say this is negative and this is positive. that means that there's a sign change in here. So that means your XR is going to become your new upper root, and your lower root is going to stay the same. So we can write that as, so by multiplying these, you're basically checking if there's a sign change, as you see here. So we multiply them, and we get a negative. So that means that there is a sign change, because the function of 5, and by the way, that just means, so the function of xl, you're just taking 5 and you're plugging it into this equation here for x. And you're just taking 7.5 for the function of xr, and you're plugging that in for x here. So that means that when you multiply these two, the function of the x lower times the function of your x guess or xr, and you get a sign change or a negative, so that means that it's less than 0, then your xl will stay the same, so xl will equal xl, and x upper will equal xr. And vice versa, so that means that if it's greater than 0, that means that there is no sign change, so that means it has to be over here. So that means xr is going to be your new lower, so xl will now become xr, and x upper will stay the same. So now that we have our first iteration done, we have our new bounds. So that means our x lower is now 5, and our x upper is now 7.5. And now we can just do a second iteration. So plugging back into that equation, finding the midpoint, we get 6.25. And once again, you could plug in to get your true error to be 2.42%. And you could plug in for your absolute error to get 20%. And we can check it again by taking our f of xl and times it by f of xr. Our f of xr was 6.25. So we get 4.5 times 0.59375. And that means there is no sign change. So that means it's going to be on this side. So now our xr will become our new lower limit, which was 6.25, and our upper limit will stay the same at 7.5. And now we can do our final iteration, finding our xr. We're going to get 6.875. Calculate our true error by plugging it in to our equation, get 7.34%. And then lastly, we calculate our absolute error. Once again, we're using these equations right here. So if you want, you can pause the video. These are your three main equations. And then also this concept right here you got to know. That's really all you got to know for bisection method. It's probably one of the simplest methods in numerical methods when trying to solve roots. I would think you might have been able to figure this kind of out on your own without even like learning it. It just makes sense by looking at it. It's like a guess and check kind of method. And that's it, guys. Thanks.